In this video, I'm going to discuss declination. So one thing to note is that compasses, depending on the location that you're at, generally do not point due north. Instead, depending on your location, your compass reading deviates from true north by a certain angle. This is referred to as magnetic declination. This is a problem when using a map because maps are oriented to true north. So you have to add or subtract the declination value when going between a map and a compass to ensure you are heading in the right direction on the ground or locating the correct point on a map. In this video, I'm going to show you how to determine your declination, and then later on I'm going to show you how to adjust your azimuths between a map and a compass. So there's two different ways that you can go about learning what your declination is in a certain area. One of the ways is if you have a map, like a topographic map put out by USGS. We're not going to use these maps this year in class, given the situation. Generally speaking, these maps will have this on them, and what this is indicating is this is true north right here, where you see the star, and then it's showing that magnetic north, and this is going to deviate from true north by 13 degrees and 55 minutes. So this is going to be your magnetic declination. A second way you can go about this is to use this NOAA resource. So you can type in this URL, or you could go Google magnetic field calculator and it would pop up. Now, if you don't know your Latin long, if you know your Latin long, you can type it right in here. If you don't, then I'm just going to put in Murray, Kentucky. You can say get Latin long, and now we have it in there. It doesn't really matter what you put here. I'm not going to go into details on what this means. We'll just stick with the WMM. And then you put the date in here, and then you press calculate. And then this is telling us that here we are at 2 degrees and 52 minutes. That's going to be our magnetic declination. In the next part of this video, I'll discuss what we actually do with this number when converting between a map to compass and compass to map. In a previous video, I showed you how to determine your destination given a location that you're at, like in Murray, Kentucky. Before I go on to show you how to convert an azimuth from compass to map and from map to compass, I wanted to first show you this map so you get a better idea of what this looks like across the United States. Here you can see the 0 degree line, the agonic line, and anything to the right here is considered a west declination. West declinations are negative. Anything to the left here are considered an east declination, and they're positive. So that's something to keep in mind because that's going to be very important when we're talking about converting between the compass and the map. Now, I went online previously and used the site that I showed you on the previous video, and I went through and I figured out what the declination was in Murray, Kentucky, Topsom, Maine, where I grew up, and Reno, Nevada. And I converted these just because it's easier to work with to decimal degrees. All you have to do that is divide your minutes, so there's degrees minutes, by 60, so 52 divided by 60 is 0.87 with rounding, so on and so forth. So you would do that for each one of these. The next thing that we're going to start with is I'm going to give you an azimuth. So let's say that we go out with a compass and we measure an azimuth of 100 degrees. Okay, so first we're going to start with going from the compass to the map. So we've used our compass in the field to get a field measurement, so a field azimuth, and we have that at 100 degrees. When you're going from a compass to a map, you want to add the declination. Okay, so what this is going to look like for Murray, Kentucky, for instance, is that it would be 100 degrees plus negative 2.87. So that's going to equal 97.13 degrees, or on your compass, you would dial into 97 degrees. For Topsom, we do the same thing, 100 degrees plus minus 15.17 degrees equals 84.83 degrees. Your compass is not that accurate, so generally speaking here, you would probably dial into about 85 degrees. Again, we're going to go 100 degrees, and here we're going to add 13.25, and this one's a lot easier because you don't have to subtract here, and that's going to be 113.25 degrees. So that's actually pretty simple. We have taken a field measurement and gotten an azimuth of 100 degrees, and then we've converted. So we know that if we're going to take in transition our field measurement and we want to plot it on a map, then we need to use these degrees over here because we've accounted for the declination. Now, over here I'm going to show you how to go from map to compass. So oftentimes you will have two different points that you're given on a map, and you'll be told, or you'll want to navigate between them. And in another video, I'll show you how we actually can get on the map azimuth from it. But once we have that, we need to convert it to be appropriate to use with the compass based on the declination. So maybe we want to go between these 2 points. Let's just say we get an azimuth again of 100 degrees for simplicity. In this case, we want to subtract the declination. So what this would look like is 100 degrees minus 2.87. So if you think about it here, we're actually adding 2.87. So that's going to be 102.87 degrees. 100 degrees for the main, tops of main. We're going to minus 15.17 equals 115.17 degrees. And then we're going to subtract 13.25, and that's going to equal 86.75 degrees. So it seems a little bit complex, but as long as you memorize this and you remember the fact that if you are subtracting a negative number, it's actually adding it, then you should be okay.